Hello everyone, welcome to our YouTube channel. And now we are diving into one of the foundational concepts of machine learning, the perceptron. Whether you are just starting out in AI or looking to strengthen your fundamentals, this video will give you a clear understanding of what a perceptron is, how it works, and how to implement it. So let's get started. So I'm writing here perceptron, right? So it's perceptron. Mm, So in this video, we are just discussing about the what is perceptron, the basic architecture of perceptron, basic architecture of perceptron. Actually, this video will be very short, and I will cover whole concept into several videos. So the difference between perceptron versus neuron in this video it will be covered. The third one is very important concept, the geometric interpretation of perceptron. Geometric interpretation. And the fourth one is actually by this actually SLP plus MLP and so on. Single layer perceptron and multi-layer perceptron. So let's come to the point, architecture of perceptron. So what is actually perceptron means? So I'm getting a point, like perceptron is an algorithm. Perceptron is an algorithm. Algorithm for supervised machine learning. For supervised machine learning. Actually, it's an algorithm, better to say a mathematical model. A mathematical model. That model helps to that model helps to determine the predictive attribute. The predictive attribute. So basically this model is responsible for binary classification, or acts as a binary classifier. So I'll come to the point later. So now let's understand how it looks like. So it's basically perceptron architecture is just like, so it's a summation function, and x1 b, x1 w1, x2 w2, and this x1 x2 1, this x1 x2 and so on, this x1 to xn are called as input columns or input attributes, input variables. If you have a data set of n input columns, x1 x2 a input column, and you want to pass on these variables into your perceptrons, then definitely the input variables will be increased, and these are the weights w1 w2 and this is specifically designed for determining your bias. So the thing totally will be looked like just hold on, just here I'm not writing. So w1 x1 plus w2 x2 plus b. Here this value will be passed on, and finally here our activation function comes. Activation function comes. This activation function, actually this is the total value. If I consider it as z, then this activation function will adjust the value of z between a certain amount of range. Like z should reside between -1 to 1 or 0 to 1. This types of things, this types of range will be determined by this activation function. So different type of activation function I can choose, like different type of activation function. One of the activation function is step function. Like if I consider the step function, suppose our z value is x1 w1 plus x2 w2 plus b. Here b is the bias factor. What is the actual meaning of bias? What is bias variance trade-off? These things are already discussed in the previous lecture series. So this bias is added to create our z value. So if our z is greater than is equal to 0, then I will set into 1. Like this is the function that determines if z is equal to 1 for z greater than equal to 0, it's 0 for z less than 0. This is the function. This is a step function I can assign for a particular scenario. Let us assume a data set like a college data set, college placement data set where IQ, college CGPA, placement status, 3 columns are there. So if I consider a student's IQ is 7, CGPA is 6.8, placement is 1. That means, yeah, that very student is placed. And if I consider a student's IQ 8, his CGPA is 5.1, placement status is 0. Again, I consider IQ is 5, CGPA 9, placement is 1, status is 1. So these types of data I'm getting from that particular data set. So right now I have to determine through my perceptron the placement status. So if my predictive attribute, if this is my predictive attribute, then sorry, IQ and CGPA will be our input parameters. Our input parameters. Okay. So let's come to the point of W. Why words are very important here. So let me take another page. And here I am already said this is my summation function, this is my f, this is b, this is x1 w1, this is x2 w2, and finally the outcome is x1 w1 plus x2 w2 plus b b z is equal to. So I have to, first of all, there is a data set and I have to train our perceptron, train. And another thing is our prediction. So it's a very crucial thing. So training is very crucial. So training is very important. So we are already given certain amount of parameters, and upon based on those parameters we have to train our perceptron. What is the meaning of training actually? So the training means that to determine the value of w1 w2 and b specifically, where w1 w2 w3 are the weights of corresponding input variables and b is the bias. So let us assume from one training we get w1 is equal to 1, w2 is equal to 2, b is equal to 5. Then 1 x1 into 1, this is nothing but a dot product. X2 is equal to 2 into x2 plus 5. This is the value of z. So it will be x1 plus 2x2 plus 5 is equal to z. Now I have already mentioned the data set, where the college data set, where I have IQ, I have CGPA, I have placement status. So if our training parameters, if our input variables are two, like one is our x1 is our IQ and x2 is our, let us take another color, and it's our, what should I say, it's our CGPA, right? So then the thing will be like that, IQ into 1 plus 2 into CGPA plus bias is equal to Z factor. Now the CGPA is the, we can check the coefficient that is 2, and here the coefficient is 1. So we can easily consider the CGPA is more prioritized value to determine the value of Z, because the value of CGPA, the coefficient of CGPA is higher than our coefficient of IQ. So to determine the value of Z, CGPA is more responsible than IQ. So that's the case of weights. That's the case of weights. Weights actually stands for the variable priority for determining predictive output. So this is the case actually. One more thing, it's very important. One more thing, actually weights determines feature importance. Weights determine feature importance. So this is the case. So one more thing I want to mention. So why it is different from neuron? So it's a very burning topic. Is perceptron is same like neuron, and what is the difference between neuron and um, our perceptron? So from our elementary biology concept, we all know that nervous system or coordination system mainly are the key components of human functionality or animal functionality. So in the same case, for generating something like in the case of machine learning model and deep learning, perceptron or neurons nervous system is also here, is a key component to determine the functionality of the machine learning model. So basically, actually, we have three type of neural architecture. One is ANN, one is CNN, one is RNN. This ANN is normal artificial neural network. This is the convolutional neural network, and this is recurrent neural network. For artificial neural network, we are just determining these basic cases. So what is perceptron, and then we will train the perceptron. We will take some or different type of values. We will predict over there, and these things will be there. And another thing is our convolutional neural network, which is based on image data. So how image data will be separated or be segmented. And the third one is our RNN, that is our recurrent neural network. So recurrent neural network is mainly responsible for textual data. And then the GAN, generative models, autoencoders, object detection, image segmentation, different portions will become. So basically we are dealing with right now we are dealing with ANN, artificial neural network, and this is the building block of artificial neural network, that is our perceptron. So now let's come to the point what's the basic difference between the normal neural network versus the perceptron. What is the basic difference? So give me another page. So neuron versus perceptron. So neuron, we all know that's the architecture, normal simple architecture. We are just like, this is dendron, axon, this is there's some myelin sheets like structure, and this is the structure, and this is the synapses. And this is the simple architecture for machine learning model perceptron. This is our simple architecture, and this is input parameters. This is our sigma, and this is our summation function, and this is our activation function. Very simple architecture. So here a lot of complex things are going on in our biological system, like this is the axon, this is how the nucleus sends the signals, then the signal will be transmitted through our axon. This is the synaptic joint, this is synaptic vesicles, a lot of things are there. So basically the thing is, this is all our cell. It's all about our cell. So neurons are communicating with each other and create a mesh. Here, perceptron also create can create a mesh to generate our signal and to make our signal fast forward to our next layer of perceptrons. This thing will be appeared in the next big video. So right now I am dealing with the basic architecture of perceptron. So This is all about the concept. And let's come to the another page, and it's all about our geometric interpretation. Geometric interpretation. So geometric interpretation of perceptron is that, like, we are already seeing z is equal to x1 w1 plus x2 w2, so on, xn wn plus b. It's just like if I consider this w1, w2, wn and x1 as x, y, z. This is the thing. So we can consider like ax1 plus bx2 plus cx3 so on to b. This is nothing but the equation of a line. Equation of a line. So here this is the case. If I consider our old column or data set, this is the column 1, this is our IQ, C2, that is our CGPA, and this is the C3, this is our placement. So this is a point 1 2 3 4 5 6 so on, this is the data. So we are taking for 2D plot of this data set, taking two variables at a time. One is our IQ and one is our CGPA. So we are taking lot of data. So this is 1000 data. Like this is the data 1. So these data are already there. So it's a very, let's write in proper way. Let's in another color. So this is the case if our equation is z is equal to ax plus by plus c. It's nothing but a line. It's nothing but a line. So the line will be like this, and this line is drawn in such a way that there is a two region are created. It separates the points into two different portions. So our step function, I have taken the step function is that if our z greater than is equal to 0, it will be set to 1, and if it's less than is equal to 0, it's set to 0. So ax plus by plus c, now I'm removing this portion. Ax plus by plus c greater than 0, that means the positive sign, this is the side, and ax plus by plus c less than 0, that means the side will be this side. So two different portions are created, one for positive, one for negative. That means our perceptron is geometrically aligned, geometrically a straight line. So what if the plot is 3D? That means we are taking three input variables at a time. So what will be the case for that scenario? So we are taking three variables, right? So one is IQ, let's say one is our class 12 marks, and one is our CGPA. And then the straight line will be changed into plane, that is our Z, and this plane will separate our whole area into two different sections. One is our greater than 0 section, one is our less than 0 section. For the 4D case, it will be an hyperplane, and for more dimension 4D onwards, it will be responsible for creating an hyperplane. So the basic thing is that the main limitation, this perceptron only handle linearly distributed data. Like if we consider these data, so these things cannot be separated by this perceptron line. This cannot be separated, this cannot be separated, this cannot be separated, so it will give a very less accurate value. So for linearly distributed data, only we can handle the perceptron cases. Later we will discuss more about this. So this is a basic introductory video on the perceptron. So it's all about today. So thank you.